Hello friends, welcome to my channel. Our today's video is about question and answer of CSWIP chapter 7. So in this video we'll learn the question and answers of CSWIP chapter 7. Chapter 7 is about materials inspection. So if you are preparing for CSWIP, then you must watch this video, and if you are not preparing for CSWIP, then also you can watch this video lecture. Before starting this video, let me give you a brief introduction of myself. My name is Sandeep Anand. I am a mechanical engineer and I am having 14 plus years of working experience, and my hobby is to share my knowledge. I share my knowledge through my website, that is weldingandt.com, and the second mode through which I share my knowledge is my YouTube channel, that is youtube.com/weldingandt. So through YouTube and website I used to share my knowledge. Friends, if you want to financially support my initiative, you can do by joining my channel. After subscribing my channel, you will see a join icon, and after pressing that join icon and by paying a very small amount, you can financially support my initiative. Friends, if you want to download the PDF of this presentation, or if you want to download any code material or study material or standard, so that you can do by from my Telegram channel. I have already uploaded many codes, study materials and standards on my Telegram channel. So in the file section you can choose and download your required document. Let's start with the question. Question number 1 is, the composition of steel is changed from 0.15% carbon and 0.6% manganese to 0.2% carbon and 1.2% manganese. Might this influence the incidence of? So friends, here if you carefully look at this question, they are increasing the percentage of carbon and manganese. So initially the percentage of carbon was 0.15% and manganese percentage is 0.6%. However, the carbon percentage has been raised or increased by 0.2%, and the manganese percentage of manganese has been increased from 0.6% to 1.2%. So here they have increased the percentage of carbon and manganese, and they are asking whether these effects will be you'll be able to see these effects or not. So let's analyze one by one. So first, our option was porosity. What will happen to porosity if we will increase the carbon and manganese percentage? So friends, if we are increasing manganese percentage, then see, manganese acts as a deoxidizer by lowering the oxygen content. So if there will be low oxygen, then chances of getting porosity will be less. Hence, the porosity will be reduced if we are increasing the percentage of manganese. Hence, our porosity will be reduced, it will not be increased. Hence this will not be the correct answer. Now option B is cracking in the weld area. Yes friends, if you will increase the carbon and manganese, then that can influence the hardenability of steel. So if the steel is more hardened, then that is more susceptible to cracking. Hence cracking can occur if we are increasing the percentage of carbon and manganese. The third option was undercut for fillet welds. Friends, undercut mostly depend on the welding parameters. If you have your welding parameter is wrong, then chances of getting undercut will be very prominent. But it slightly depend on metal composition also. So more carbon will slightly increase the undercut. More carbon will slightly increase the undercut, but welding parameters and technique play a very significant role. Hence, now we'll look at the fourth option. Fourth option is lack of root fusion defect. Friends, when we increase manganese, so the increase in manganese it improves the root fusion. If you will increase manganese in steel, then that will improve the root fusion and it will provide better penetration and fusion in the weld. So our first option, that is porosity, will not be increased. So this will not be the correct answer. The last option, that is root fusion, that is also will not occur. So option B and on option C, the most appropriate answer is option B. because this is significant. If you will increase the percentage of carbon and manganese, then cracking will be significant. The hardenability will be increased and the cracking may increase. So this option is very significant. So this is the most appropriate answer. While undercut, yes, undercut may increase, but undercut mostly depend on the welding parameter. Hence, the chemical composition will play a less significant role. Hence, our most appropriate answer will be B, cracking in the weld area. Now question number 2, which of the following alloys is non-magnetic? So friends, this is a very simple question. Non-magnetic, see, we have 4% chromium moly, 12% chromium, austenitic stainless steel and 9% nickel steel. The first two option is not correct because chromium and molybdenum are magnetic. So whenever there is chromium and high percentage of chromium and magnetic and molybdenum, then that will be magnetic, that will not be non-magnetic. Now option C is austenitic stainless steel. Yes, see friends, austenitic stainless steel is in general non-magnetic alloy. But if you look at the option D, that is 9% nickel steel, see here also nickel is there, so 9% nickel steel is also non-magnetic. But if you have to choose the most appropriate answer, then the most appropriate answer will be C, because the 9% nickel steel is generally non-magnetic, but they have very minimal magnetic effect also, minimum magnetic effect. The option A was alloys with chromium and molybdenum are typically magnetic. So this is not the correct answer. 12% chromium is also alloys are usually magnetic. Now austenitic stainless steel is the most appropriate answer. It is having high nickel content and the cubic structure is face centered cubic crystal structure and they are non-magnetic. However, 9% nickel steel is also non-magnetic, but they are having, if you will compare between these two, then austenitic stainless steel will be the most appropriate answer, because 9% nickel steel may show minimal magnetic effect. There will be some minor magnetic effects. Now question number 3, addition of which element in steel increase its toughness at sub-zero temperature? So sub-zero temperature means temperature less than 0 degrees Celsius, means in cold conditions. So see, nickel and molybdenum, these both increase the toughness of steel, but at lower temperature or at cold conditions, nickel increase the toughness, and at elevated temperature molybdenum increase the toughness. So at sub-zero temperature, nickel will be the correct answer. See here, when it comes to toughness at sub-zero temperatures, nickel is often more prominently associated with this property. Nickel helps maintain ductility and impact even in cold conditions. So in cold conditions, it helps maintain the ductility and impact resistance, and impact is the toughness. Now molybdenum indeed plays a crucial in improving the toughness of steel, especially at elevated temperature. So at elevated temperature, moly will play the role, and at sub-zero temperature, nickel will play the role. Now question number 4, which of the following elements help in improve creep properties at elevated temperature? So at elevated temperature, molybdenum, it helps in improving the creep properties of steel. So option C will be the correct answer. Molybdenum improves the creep properties of steel at elevated temperature by forming stable carbides, inhibiting grain coarsening and enhancing resistance to deformation through solid solution strengthening. See, if you want to understand layman terms, let me explain this. See, in general, you can consider molybdenum as a superhero for steel at high temperatures. At high temperatures, what it does, so at high temperature, it forms special structures. What a special structure? Nothing but this stable carbide, inhibiting grain coarsening and enhancing resistance to deformation through solid solution. So in general terms, we can say that it forms some special structure that prevent the steel from getting weaker and deforming when it is hot. So at higher temperature, molybdenum will play the role. So if you want to understand in more general term, see, consider a building. So in building, what role the reinforcement plays? Reinforcement increased the properties, increase the creep properties or increase the toughness of the building. So like reinforcement in civil, in for steel it is molybdenum. Now tensile strength can be increased in steel. So friends, tensile strength, just a second, there are some marks, okay, don't okay, no problem. Tensile strength can be increased in steel by annealing, galvanizing, addition of carbon and casting. So four options are given. Annealing, galvanizing, addition of carbon and casting. So I'll give you 2 seconds to think what will be the answer. How tensile strength can be increased in steel? Okay friends, so some may say that the answer will be annealing and some may say that the answer will be addition of carbon. So when there are 4 options and you have to choose one, you need to choose the most appropriate answer, and the most appropriate answer from my point of view will be addition of carbon. So in general, from general definitions, general definition says that if you add carbon to the steel, it will increase the tensile strength, whereas annealing increase the ductility. So carbon is common alloying element in steel and contributes significantly to its strength. But there is one exception, that you will increase the carbon content, the strength will be increased, but after a certain limit, when you will increase the carbon, the hardness and brittleness will be increased after a certain limit. But in general terms, it is said that whenever you will increase the percentage of carbon, the strength of the tensile strength of the carbon will be increased. So the most appropriate answer will be addition of carbon. Now annealing is a heat treatment process and it is often used to improve the ductility. So if you will improve the ductility, that will indirectly improve the tensile strength. But in general terms or in general concept, annealing is used for commonly used for saying that it improves the ductility and reduce hardness, and addition of carbon is used for increasing the tensile strength. Now question number 6, which of the following chemical elements has the greater effect on hardenability of steel plates? So what is hardenability? Hardenability is nothing but the ability of steel to be hardened through heat treatment process. Means how fast steel can be hardened through heat treatment process is called as hardenability. Now we have 4 options: moly, chromium, titanium and carbon. Among the 4 options, carbon is the correct answer. Carbon has significant impact on hardenability. So carbon is the correct answer. Now question number 7, to prevent the hardening and cracking of high carbon steel plate during flame cutting. So during flame cutting, if high carbon steel you are using, so you need to preheat the plate. If you preheat the plate, the steel will cool slowly, or the reduce the temperature gradient. Hence the option A will be the correct answer. Now recrystallization during annealing. So during annealing, recrystallization is done. It is used to make steel. So annealing is done to make steel softer. Option A will be the correct answer. Annealing is done to make steel softer. Now question number 9, this is the last question. On which of the following you will not be able to perform MPI? So friends, MPI is magnetic particle inspection and it can be performed on any material which can be magnetized. Now it is asking on which material you will not be able to perform. So if the material is non-magnetic, then only we will not be able to perform the MPI. So we'll see the answer. Option A is low carbon steel butt welded joint. See, butt welded joint is nothing but they have given to deflect your mind. See, you will see the material, you have to see the material, low carbon steel. So low carbon steel can be magnetized, hence here MPI can be done. So on low carbon steel you will easily you can do the MPI. Now second option is austenitic stainless steel. See friends, on austenitic stainless steel is non-magnetic, and on non-magnetic item you will not be able to perform MPI. Hence in austenitic stainless steel fillet welded T joint, you will not be able to perform MPI, means this is the correct answer. Now option C is a medium carbon steel. See, on medium carbon steel also you will be able to perform magnetic particle test, because this can be magnetized. So option B will be the correct answer. Option B, that is austenitic stainless steel fillet welded joint. Friends, I hope you like this video lecture series. Thank you very much.